Okay, so this is derivatives day 3. You've had 2 days of doing derivatives with the rule. Now we're going to learn something called the power rule. And if you notice here it says easy derivatives, and you will find out very quickly why that's called easy. So it says there's a pattern for taking the derivative of polynomials. Now this really only works on polynomials. We're going to have to use other rules for other types of functions. Okay, so let's look at a function and its derivative. X squared plus 5x minus 3, its derivative is 2x plus 5. Now, if you notice the 2 from right here and the 5 from right there. So let's see if we can extend this pattern. Okay, so notice on the next one, I'm going to go ahead and tell you that each term works individually. This is why this works on polynomials, because it's made up of individual terms. So here I have 4x cubed equaling to 12x squared. All right, so we've got a 3 and we've got a 4, and here we've got a 12. Okay, let's see if we can develop a pattern. We've got 5x squared. Again, we've got a 5 and a 2, and down here we have a 10, and then we have a 3, and then this 7 kind of drops off like how the 3 dropped off. All right, so we're kind of developing this rule, but I want to go ahead and tell you what's going to happen each time. Each time you're going to look at the term, you're going to take the power, you're going to multiply it to the coefficient. That's your new coefficient. And if you notice on the power, it goes down by 1 each time. Okay, so let's develop this further. 2 times 5 is 10, and now the power on x is 1 less, which makes it just 1, or just x. Here you could kind of almost make the exponent become 1. 1 times 3, or negative 3 is negative 3. And then if I make the power on x 1 less, that's x to the 0, which is no x at all. All right? Now, if you think about, you may think, well, this is an exception. It's not. If you think about, if I put an x here and I put x to the 0, that would be the same as what was originally typed. 0 times 7 would be 0. You wouldn't even do a 1 less on the power because it is gone. Okay? So what the power rule is, the derivative of a term with respect to x is always going to be, you're going to take the power, you're going to multiply it to the coefficient. Okay, so in this case it's just n. And then what happens to the power? It becomes 1 less. Okay? Now if you just have a constant, the c represents a number like 3 or negative 3, like 7. Always, always, the derivative of a constant is 0. Okay? Now, here are a couple others that I'm not going to go into why, but I'm going to go ahead and tell you that the derivative of sine is cosine of x, and the derivative of cosine is negative sine. This is worth memorizing. You will use this so much next year, it is worth your time to memorize it. All right, now let's do some examples. So we're trying to find f prime of x. That's what the derivative is. So we multiply 4 times negative 4, that makes negative 16, and then we put the power 1 less. So now the power is cubed. Okay, now we get to the second term. 3 times positive 7 is positive 21, and then we make the power 1 less. Next term. 2 times negative 2, that's negative 4, and then we make the power 1 less. We just leave it as x. On the next one, we have like a 1 times negative 10, so that makes negative 10. And then we don't write an x at all, and we definitely don't write a 9. That goes away. The derivative of 9 is 0. Okay, so for the next part, this is what we had kind of done in part 1 and 2. What's the slope of f of x at x equals 1? So what we're finding now is f prime of 1. So let's plug in a 1. And this is something we can do without a calculator because the number 1 is very easy to take powers of. Okay, so negative 16 plus 21, that's 5. 5 minus 4 is 1, and 1 minus 10 is negative 9. Okay, now we get into g of x. Now this is not a polynomial right now. I can make it into a polynomial, and in fact, you have to do this in order to use the power rule. Okay, so what I'm going to do first is split everything up. Now you can do this with the denominator. You can't, when your denominator is just one term, you can split it up this way. If the denominator had been anything other than one term, I would not have been able to do this. Okay, And I'm going to just go one step further and I'm going to simplify what I can. So that first term just becomes 5x. The second term becomes 3 over x, but I'm going to write it as 3 to the x to the negative power. And then what would the power on x be for this last term? -2. Now this is not quite a polynomial, but we can treat it like a polynomial. We can use the power rule. So we're finding g prime of x. So let's look at the first term, 5x. The derivative of that is just 5. All right, now -1 times +3. That's -3x, and we need to go one less. That's going to be a -2. Always one less. All right, -2 times -7, that's +14. And one less on the power becomes a -3. Okay, so this is really okay for your answer. If this bothers you, or if you were going to use this for something else, you might want to make it look more like the original problem. And that is really not that hard to do. The first thing I'm going to do is kind of just working backwards from what I did before. 5 minus 3 over x squared plus 14 over x cubed. What would the denominator be? It would be x cubed. So I need to multiply the 5 times the x cubed. I only need to multiply the 3 by an x, and the 14 stays as it is. Okay, so this is another way to write it. Honestly, the first way is fine. The only reason you would nearly need to change it is if you were wanting to use this for something. This right here might be a little bit easier to work with. Okay, let's look at number 3. Here we have some trig in here. So we're not really doing this, though, any different. We're still just taking f prime of x. Pi is a constant, so we get to just multiply pi times the derivative of sine. Now, if you remember, the derivative of sine is cosine. Again, it's worth it to memorize. All right, 3 is another constant, so I get to just multiply 3 times the derivative of cosine. What was the derivative of cosine? Negative sine, so this becomes -3 sine x. And this is going to feel a little strange, but you will get used to it and it will become just one of those things that's easy for you. Just takes a little bit of practice. Okay, so here we have another problem. It doesn't look like a polynomial. We're just going to do a little bit of algebraic work to make it look more like something I can use the power rule on. So I'm going to change square root of x into x to the 1/2, and I'm going to go ahead and rewrite the denominator as 4x squared. Okay, this 5 over 4 cannot be simplified, but I can combine these two by subtracting. 1/2 minus 2, that gives me -3/2, or -1/2. I'm going to go ahead and make it into the improper fraction. That's going to be easier to work with. All right, now f prime of x, power rule. -3/2 times 5/4. That's going to be -15/8. If you just multiply numerator to numerator, denominator to denominator. And now I need to do 1 less. So I need to subtract 1 from -3/2. If you need to do scratch work over here to make sure that you don't make a mistake, do that. Okay, you end up getting -5/2. Some of you better at fractions than others. You can't afford to make mistakes because you don't know how to subtract fractions. That's just not going to fly in calculus. Okay, so here is my answer. We could definitely rewrite it to make it look more like the original problem. I'm not going to spend a whole lot of time on that, though, in this lesson. All right, number 5, we need to rewrite 1 over x as x to the -1. How would I write the next one? What would the power on x be? 1/3. So then I'm finding f prime of x equals -1, or just negative, times x. 1 less would be -2. All right, 1/3 times -4, that's -4/3 x. 1 less, I'd be subtracting 1. That's going to give me -2/3. And again, this is messy, but this is your answer. And we could work to make this look more like the original. Again, not the point of this lesson. Okay, number 7. All right, so looks like everything's kind of already worked out. Just this one last term. I'm not going to rewrite the whole thing. I'm just going to rewrite this as x and then the power is going to be 3, and the root is going to be 5. Okay, so now I need to find the derivative of p. And you should be able to do this by now. Okay, hopefully it's becoming just a little bit easier. Negative 3 times negative 6, that's plus 18x. We put a negative 4 on that power because we go one less. On this next one, you take the derivative of cosine and then just multiply it to your negative 5/2. So the derivative of cosine is negative sine, so this is going to change this into plus 5/2 sine x. And then the last one, 3/5 times my coefficient, which is 1, so just 3/5 x. And again, if you're not sure what 3/5 minus 1 is, do some work off to the side. It's negative 2/5. And that is your answer. Okay, number 8. This looks like it's way different. And later on I'm going to give you a rule for dealing with something in this form as it is. But right now we don't have knowledge of how to do this. So we actually are going to have to just multiply this out. So when I square 2x plus 1, that is going to give me 4x squared plus 4x. Take as many steps as you need to do this, plus 1. And when I multiply 5 through, I get 20x squared plus 20x plus 5, which you should be able to do the derivative of this. So h prime of x is equal to 40x, just using the power rule, plus 20, and that's it. There's your derivative right there. Okay, number 9 says, find the equation of the tangent line to the graph at x equals negative 2. Well, we know anytime we see this equation of the tangent line, our first thing we have to do is find the derivative. So the derivative here is 6x minus 2. I'm just using the power rule. Now the slope of that tangent line is going to be f prime of 2, which is going to be 12 minus 2, which is going to be 10. Okay, this is the slope of that line. Here's the x value of the line. How do you find the y value? Well, you just plug it in. You do f of 2. So this is going to give me 9. There we go. So our point is 2, 9. And we do slope-intercept form, or point-slope form. Y minus 9 equals 10, parentheses, x minus 2. Leave your answer like that. You could multiply it out and simplify it if you wanted to, but this is fine. Okay, bring your questions to class.